Hi, everyone. Welcome back to Tech Talk, a podcast where Amit and I talk about various technology related topics. Today, we're going to talk about a topic called UTC. A lot of you will know about UTC. It's to do with time zones, but UTC doesn't necessarily refer to time zones. It refers to a standard, as Amit just briefed me right now. Um, I find it quite interesting, although I don't know a lot about it. I know some. Hopefully, I'll be able to share those with you guys and help you guys. But a lot of Amit came up with the topic, and it's a quite an interesting topic. And the first thing I was curious about is UTC, standing for Coordinated Universal Time. But the abbreviation of it, the letters are a little bit jumbled together. So there must be a story there, and I'm interested to know the story behind it. So yeah, Amit, start us off with UTC. What is it, and potentially the story of why the letters are UTC.
Yeah, so thanks a lot, Rinat. And again, UTC, the reason I recommended was because as software engineers, we use a lot of timestamps, and most of the timestamps in our code, in anything we do, is always mentioned in UTC, because software is not used just in one country or one location. It's used across different locations, and every location has a different time. So how do you have different time, but define it in a way that it works across multiple geographies? And that's where the standard comes, UTC. So you don't define the time as BST, British Summer Time, or GMT, Greenwich Mean Time, or IST, Indian Standard Time, or Bangladesh Standard Time, etc. So these are all the different time zones, and each time zone has a different time, but they are all with respect to UTC. So we could be UTC. So currently UK is at UTC plus one. So because we are 1 hour ahead, because it's summertime, in the winter, because of the daylight savings, we'll be on UTC. And India and many other countries, they'll be UTC plus 5, plus 6, plus 4, or UTC minus 6, minus 7, minus 8. So when we write code or anything, say navigation of aircrafts or GPS satellites, anything, and we have to coordinate where they are in what time, we cannot write, okay, this is the time based on, say, BST. Okay, it is BST, but what does it mean if it was flying over, say, Nepal? So how do we calculate the time? So rather than doing all this calculation, it's better to have a standard and then represent the time zones in that standard. And that's where UTC comes in. UTC stands for Coordinated Universal Time. So it has universal time and it is coordinated. Coordinated between what? And that's the story behind. I'll explain it. But the abbreviation, so that's very interesting. Coordinated Universal Time stands for CUT. But in France, it said Temps Universal Cordon. Temps Universal Cordon. So it's TUC. Okay. Now, of course, if you translate this into multiple languages, you'll have multiple abbreviations. So, how do you create an abbreviation that is not favoring one country or one nation or one language? So, that's why they came up with the concept of UTC, because UTC itself will not, it's not present as an abbreviation in any language. So it doesn't favor any particular language. So that's one good thing. Plus, it has universal time in it, and universal time is one of the standards which UTC follows. So it makes sense to name it UTC instead of CUT or TUC or anything else, or CTU, etc. So UTC is that. Now, when I say coordinated, coordinated between what? I'll just quickly go through it. Coordinated between atomic clocks and the solar time. So there are high precision atomic clocks. An atomic clock means they measure the frequency of a particular of a particular radiation emitted by certain elements, and they measure like in 1 second, or how many frequencies uh, translate to 1 second, and that is defined as one standard. And then you have the solar time. So how much time does it take for the Earth to rotate from one noon to another noon with 0 degree, which is GMT line at the prime meridian in UK, based taking that as reference. So how much time does it take for Earth to rotate from one noon to another and looking at the stars? Okay, so it is not to do with any atomic clock. It's just to look up in the sky and see how much time it takes for Earth to rotate once, noon to noon. Okay, at any given point in time or at any given place in time. And based on that and the atomic clocks, then we decide the UTC time. And that UTC time is used across all the servers in the world. It's used across by all the timestamps, whatever system is working on. It's used by aircrafts, it's used by GPS systems, it's used by anything that needs high precision time works with UTC.
Right. Okay. That's actually quite interesting to know about. I mean, yeah, I've been confused with different time zones, and as you said, as software engineers or people in IT, you are very likely that you will have teams all over the world, because IT work doesn't necessarily require you to be present physically present in a particular place. So you can just log in or wherever there is internet. So usually there are teams all over the world, in different time zones, and you have to coordinate between between all the teams and the meetings. Obviously, those are less to do with actual software development or things like that. But you have to kind of struggle with the calculation of time zones all the time anyway. And having a standard really makes it easy. And as you said, I mean, when you were talking about standard in terms of standard time, or I was thinking standards are really a reference point.
Exactly.
Whenever we
Yeah.
have a metric standard, and a meter is a reference length, which is everything else is measured against. The same way, I think UTC is the reference point, which is the standard, which is same for everyone. And our traditional map that we use, where Greenwich in London is the actual midpoint of the Earth when it's
No, no,
just.
no. It's not the actual
No,
midpoint of
is it
Earth.
not?
No, no, no.
No, 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 absolutely not. That's what I'm saying. Like traditionally, like this is how it kind
So,
of happened.
so there was a conference and they all decided, okay, where should the 0 degree be?
Hmm.
I think we should talk about longitude and latitude first before we
Absolutely.
explain 0 degree.
Yeah, yeah, but no, I was just basically pointing out that it is, at the end of the day, UTC, the standard, is basically a reference point from which the rest of the time zones are measured. For example, you know, in India, Nepal, or Dubai, plus as you go east, you plus hours or halves of hours, etc. And as you go west, you sort of subtract them from the reference point. But yeah, the reference point is there to help us all to sort of to conform to that standard, so we can all sort of agree on a sort of how do I put it? Agree on a time which is
Yes.
acceptable by all. I remember reading an article, or probably a YouTube video about Australia having very weird time zones in different states, but that's probably another conversation. But yeah, I
Of
mean,
course.
it could get very complicated with different time zones in the same country or in the same state, for example. But having the reference point makes it a little bit easier for everyone. And yeah, the reference point in this case is UTC, or the standard sort of the time zone. But one thing that confuses me, Amit, that when you're talking about what UTC is, the zero, which is not plus any hour or minus any hours, but that's really Greenwich Mean Time, isn't it? I mean,
So
Greenwich Mean Time
Greenwich
is the
Mean
same
Time used to
as
be the
UTC.
standard. Now it has become
Mhm.
a time zone.
Right. Okay. So, but whenever we're talking about UTC what time is it in UTC? It's always the same time when
So it used to
as
it is the same time GMT
Mhm.
in UTC when it's winter in UK.
Yes,
But
yes.
in summer we have the British Standard Time, which is BST,
Yeah, yeah.
which is one
So
hour ahead.
in summer, all over England or Britain, we have 1 hour ahead. That's also fine. But the GMT time zone is always existing.
Yes.
BST is just
So
+1 from
so GMT
GMT.
used to be the standard, but now it's not a standard. It is now a time zone. So actually, we need to understand the different time zones as well. Okay, and for that we need to understand latitude and longitude. So Earth is is a sphere. Okay, and if you draw a line horizontally across the sphere and vertically across the sphere, that's what gives you the latitude and the longitude. All the horizontal lines across the sphere, going right from the middle as well, is called a latitude. The biggest latitude or the longest latitude is at the equator because it's at the furthest circumference of the sphere. The longitude line goes from the North Pole and the South Pole, and these are vertical across the planet or Earth. These vertical lines go across the planet. Now, for the horizontal line, there is a reference. The most middle part is the longest, which is at the equator. Anything above or below will be shorter. So everything is measured with respect to equator. So we have some degree north, some degree south. So that's with so when you give coordinates, so geographical coordinates always has 2 points, one for north or south and one for east and west. North or south means distance from the equator. So are you 0 or 10 degree north of equator or 10 degrees south of equator? And east or west is from the GMT line. Now, for a horizontal line, we have the reference, which is the equator. But for the vertical line, all the lines are same. So how do we define it as a reference? Or what line should we define as a reference? Because all the lines are going through and there is no one place where it is, I mean, you cannot say that, okay, it is the longest circumference is at the equator because it's going vertically. Okay, so it has got a
Yeah, that's
completely
that's
different
actually
meaning.
quite interesting.
So now,
Yeah,
for
yeah.
people in olden days, when they were navigating on sea, they always had to carry uh, a clock. And how would they carry a clock? They would measure, okay, I'm leaving at noon tonight or today from England, from the shore of England. And I note down that, okay, it is this time. So I now keep calculating, okay, tomorrow what time does noon come? Because I've traveled, say, east or west. And based on that, I can tell how far away I have moved from England. But this was not a very accurate science, and they needed a way to figure out how to actually measure time as you move east or west. North and south is fine. If you go up north or up south, the amount of sunlight is same. But if you go to east or west, the amount of sunlight changes because Earth also rotates. So because of the Earth's rotation, the light from east to west changes, but the light on the same latitude, sorry, the light, if you take of any vertical line on that particular line, the light is always the same. Okay,
Yeah.
so if you take the latitude as you go up and down on the same vertical line. So say you take one longitude at 0 degree, which is at the GMT, and then you go up 10 degree north or 10 degree south. The amount of light is the same. It means that the time on that particular vertical line is the same. So that's what uh, longitude is representing. You go up or down on the same line, the time is same because the amount of
So
sunlight is the
what
same.
when you say amount of sunlight, you mean like the time amount of time the sunlight is present, the duration of the daytime. Is
The
that
duration of the daytime
right, right?
or the brightness of the sun. So it's that, but the time is the same. So now okay, so let's go back. So horizontal and vertical lines, horizontal is latitude, vertical is longitude. We needed to have a reference. Horizontal we had equator, vertical we didn't have anything. So there was a conference and they arbitrarily decided, as with any standards, everything has to be English or British. So it
Mhm.
became GMT, Greenwich Mean Time. So there is a place in Greenwich. If people who visit London, they can go to the Greenwich Park. There is an observatory there, and near that observatory, there is actually the GMT line, the Greenwich Mean Time line. So that line defines, okay, if you go east, time increases. If you go west, time reduces. And for every longitude, you have, I think, +4 or +5 minutes. And that's how you decide, like, okay, is it half an hour, or is it 1 hour east of the GMT line, or is it half an hour less or 1 hour less west of GMT line? So that's what the GMT line represents. If you go east, the time increases. If you go west, the time decreases. Now, time is a very crazy thing. We always measure time against something, and that something is also arbitrary. So, time is actually not something that's fundamental to the universe. So we think time is fundamental, like mass or gravity or electromagnetism, but it's not. Time is just a series of events, and we have defined it in that way. For a atom, it doesn't matter. I mean, if you look at the fundamental equations, it doesn't matter how you play those, how the reaction occurs or how the physical events occur, because there is no time in it. It can happen the same backward or forward. But because of entropy, because there is a randomness every time a physical reaction happens, that's when that's where you need time. And for us, because we grow old, we have to define time. And time always moves forward, moves ahead. We cannot go back in time and change things. I cannot go back in my past and like clear an exam and become very rich. It's what it is. Anyhow, so you have the vertical standard at the GMT and the equator. With this, now whenever you move towards the east of GMT line, not east as in east, if you're outside Earth, east or west doesn't mean anything. It's just a sphere. So you can go anyway, and you can go east could be any direction. It's just something that we have defined for our own benefit because we are on this planet. So if you go east of the GMT line, the time increases. But if you keep going east, 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 you will come back to the same line because Earth is a sphere. So you come back and you finish us around, and you come back and you finish us one circle. And once you finish, your time resets. So there is something called as an international date line. If you go forward, you gain a day. If you go backward, you lose a day. So that's where they have defined, okay, we will go minus up to the international date line, and we will go plus up to the international date line. So there is GMT line and there is international date line. So you will go plus 4 minutes, plus 4 minutes, plus 4 minutes, or plus 5 minutes, still the international date line. The moment you cross that line, it stops. No more plus. And if you go minus, say you go minus 5 minutes, minus 5 minutes, minus 5 minutes, the moment you reach international date line, it will no longer be minus. So this is all that what is needed to actually define time on Earth.
Yeah, and interestingly, because it's like equally divided, the deadline is exactly opposite, I think, of GMT line, right? So that's why you
It's
would
somewhere
go
in the
plus
Pacific
plus plus
Ocean.
12.
Yes. It's somewhere in the Pacific Ocean.
Yeah, yeah. So it's between Alaska and Russia, I think.
Something. Yeah.
Yeah, yeah. And so basically, whichever way you're going, you go plus 5 minutes, plus, 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 and you would reach until 12, plus 12, or minus 12. You wouldn't go more than that because then you would reach the next day, essentially,
Exactly.
or the previous day.
Yes.
So, yeah, that's very interesting. I mean, within 5 minutes of travel, you could literally gain a day or lose a day. It's
Exactly.
I find it very interesting. But it's again, as to emphasize, as you said, it is an arbitrary point. We've decided, Greenwich in London is the 0 degree, and then because of that, the right exact opposite is going to be um, where the dateline would have to be.
So yes, you're right. We needed to define something, but it's all arbitrary and it is for our own
Hmm.
benefit. Now, I mean, we have defined the longitude, we have defined the latitude, we have defined coordinates, so we can see whether we can go up or down, and east or west, and based on that we can. So based on that, you can locate someone, and using those same principles, we can also identify the time. Now, each country has a time zone. So if you are in UK, you are part of a time zone. So it means that anywhere in UK, it will be the same time. If you go east or west on the on in United Kingdom, you are on the same time zone. So the time doesn't change for you. But if you go from UK
Yeah,
to
and
France, then the time zone changes.
Yeah, and this is also again to make our daily lives easier, because if you are really granular and if you're really thorough, then going a few miles would change essentially the time by 5 minutes or not. But in real life, in daily life, as you are moving about doing business, going from one place to another, it would be quite difficult to keep track of every 5 minutes, every few miles you travel, and then the time is changing. So that's why it was again arbitrarily created time zones. So okay, let's finish this, but I have a question about the coordinates that we just talked about, you just
So,
explained.
so when we talk about time zone, what it actually means, suppose you wake up from your bed at 7 in the morning in UK. What do you think should be the time, or where should you think the sun should be in, say, Japan? Should it be midday? Should it be 7 a.m. in the morning? Should it be 11 a.m. in the morning? Or should it be some 7 p.m. in the night? Japan is quite far from UK, right? And Earth is rotating constantly. So it means the amount of sunlight that you get at 7 a.m. in the morning in UK is not the same as the amount of sunlight that you would get in Japan. So it means that they need to be on a different time zone to adjust. So 7 a.m. in UK might be 7 p.m. plus 12 in Japan, because it's dark there now, because sun has set for them. They're ahead of us in terms of rotation, because you go plus plus plus. That's why you have time zones. So as you move across from the GMT line to the east, your time zone changes. So it means if it is 7 a.m. in UK, it could be 8 a.m. in France. It could be 9 a.m. in so it could be 7, 8, 9 a.m. in Serbia. It could be 10 a.m. in Turkey, 11 a.m. in Pakistan, 12 a.m. in 12 p.m. in Bangladesh, and then so forth till you reach Japan. It's the same time for you, but with different amount of sunlight. Because it is different amount of sunlight, the day is just a bit different. So if you want to have the same 24 hours, you need to shift the time so that everyone gets their 7 a.m., everyone gets their 7 p.m., and everyone sleeps and everyone works when it's bright and sunny, and everyone sleeps when it's dark and the sun has set. So that's why you have time zones. And time zones define that the time in that particular zone is same. You go plus or minus in that particular region, it doesn't matter. The time is same in that time zone. So India has a very weird thing. India is huge. So when your country is huge, you normally tend to have different time zones. But India has only one time zone. So east to west. So when it is 6 a.m. in east, it is 6 a.m. in the west. But because the west is so far, the sun has actually not risen. So it's still dark. But in the east, the sun has risen and it's bright and sunny. But here in the west, say in Gujarat, it's dark, but there in Arunachal, it's bright and sunny. And that's a weird thing, because here, one place where it's bright and sunny, people are happy to wake up. But where it's dark, people are not happy. They still want to sleep a bit more. And that's why time zones are so important. And then we have this daylight savings time between in UK and many other countries. So basically what happens is in summers, as you go up the equator, the days get longer, and then the days get longer up to June in northern hemisphere, and the days get longer up to December in southern hemisphere. And after June, the days start getting shorter till December, and in the southern hemisphere, the days start getting shorter till June. So that's the cycle that follows. Now, because the days are getting shorter and longer, they had to adjust the time. So people gain an hour when it's winter and they lose an hour when it's summer. And because of that loss and gain, people have to adjust their clocks. And that adjusting is actually quite a hassle. Sometimes people forget to adjust their clocks. If it's a digital device, it gets updated automatically. But if it's a manual device, you have to update it physically, and that sometimes causes issues. So yes, so in UK you gain an hour and you lose an hour depending upon whether it's winter or summer, and that is only because people so that you give people additional daylight, and that's what the intention was. But because you are changing the clocks in summer and winter, sometimes it confuses people and sometimes people forget, and that causes a lot of issues because if you don't
Yeah.
update your clock automatically, then it can
I
tell you incorrect time.
Exactly. I mean, to be honest, there's so many funny stories about that. But one of the I remember this used to be a much bigger issues, and a lot of people would used to have this as mistake. Back in the days in 2007, 10, or even earlier, when there were more analog clocks rather than digital ones. Nowadays, obviously, with the advent of technology, most of our phones and computer clocks and some other like digital desk clocks as well are connected to UTC, and they update the time based on the dates. From the internet. So that's actually pretty cool. But I remember, you used to, in some of those situations, used to come to the office or come to school an hour later. And I remember some of us, or not me, I don't want to say if it's me or not, but knowing that it's okay to make that mistake, you could intentionally make that mistake and be an hour late to your university class and everything. I mean,
For
I
one
was
day,
what.
for one day in the year.
Yeah, yeah. So that was many funny situations that would happen. But
Yeah, it's sometimes I remember when I came from India, because in India you don't have a concept of daylight savings. So when I first came to the UK and we had the daylight savings, I was just watching a film and it was 2 o'clock, and then I saw almost an hour of video and then it was still 2 o'clock. I was like, what happened? Did I lose time, gain time?
uh,
What happened? And that was the first time I experienced daylight savings. Like
right,
it was
yeah,
crazy. Like it seems like I gained 1 hour, and it was actually winter when I first came to the UK. So
exactly.
it did make sense, and this was my experience, and it was totally bizarre. And it still is
Yeah.
bizarre for me because I have to. Some of the wall clocks are still analog, so I have to manually change
Hmm.
it. All the smartphones, laptops, they get automatically changed. Even my smartwatch, the moment because it's connected via Bluetooth, it automatically gets
Hmm.
updated. But anything else, I have to change it manually. And sometimes you forget that okay, the clocks are changing, and if it is +1 or -1, and it causes a lot of hassle. So people have been thinking about having say multiple time zones in Europe and getting rid of the daylight savings. US, it seems, has almost 10 different time zones because it's a huge country. So it has to manage
Hmm.
times across so many different parts that they have a lot of time zones, and each time zone sometimes have daylight savings. So you have to. So imagine, so all the time zones are there, and they manage time for that particular region. Now they all go plus or minus depending upon whether it's summer or winter, and you have to manage all that with the time zone. Now, if someone, a programmer or say an aircraft pilot or a satellite engineer, they have to manage the time. How many times do you think they have to change all this? So someone has to track all that, and it has to be tracked against a standard. So that's it. All comes down to UTC, and it is so that all these issues can be solved. So we represent time with always UTC. So if it changes daylight savings, it is UTC plus 1 or UTC, or it is UTC plus 2 or UTC plus 2.5. It's always UTC. It's the standard, and you
Yeah,
represent that time
exactly.
zone in that standard. That's what it is.
Exactly. I mean, there could be so many. I mean, as you said, there are so many time zones, and then there are temporary time zones like British summertime, etc. And some of those time zones, I was talking about it earlier. Like for example, in Australia, like obviously you have different time zones to relate to the sun. Where it is in the time of the day, but as you go east and east and east, you obviously from GMT, you reach Australia and you reach the first time zone. But then within Australia, there are so many time zones, and some of those time zones are defined in an area which is actually, plus, but geographically located west of the place because the way it's divided, the land area that's defined for that time zone, part of it falls further west of the one that is above the land area that is above the first land area. Probably confusing the audience by being vague. But yeah, I mean, look it up, Google it. It's quite interesting, Australian
I
time
can
zones. And
imagine. I can think about it. Like you have, say, you have a zigzag line, so it starts
yeah.
from the north and then it goes west and then it goes down south and then it goes east. Because of all that,
hmm
and if there is something north of it, it's crisscrossing, and then the time zones are that's why a bit bizarre. So
Yeah,
yeah, it does make
exactly.
sense.
But yeah, as you said, like there's so many of these, it's very difficult to keep track. And with technology and IT, now everything is global. You know, you send an email, now as a recipient, you need to know, you want to have those sort of emails or any communications in your time zone where you are, because that's what you're experiencing in real life. But the person who sent it to you is probably in a different time zone altogether, in a very complicated time zone. For example, if I text someone in America right now, they well, they also have the summertime. But say, for example, if I text someone in Turkey right now, I don't know if they have summertime, but I'm in British summertime. Turkey is in its standard Turkey time. I don't know what the three-letter abbreviation is for that, but yeah. So now, WhatsApp has to then do the calculation that I've sent it, but I haven't sent it from GMT time zone. I've sent it from BST, and then adjust based on that. And if the recipient was getting the time when from the sender's destination, they would be quite confused because they would have to then sort of recalculate in their head, which is not the ideal thing to do. And for all of these things happen in IT or in technology or in digital world automatically, which is tailored for you as a user based on where you are. And that's quite convenient. That's really convenient, especially if you're having messages from five different people in a group chat from five different geographic location. How would you ever track that? So all of these things are possible because of setting up a standard reference point from which all of these calculations are done automatically before it even reaches you. So a lot of hassle or confusion is kind of
Yes, and even
doesn't really.
even with the satellites, because and GPS, the Earth is rotating, satellites are rotating, and they have to measure the time across where they are on the planet, and they have to measure it precisely so that they don't lose time or gain time, and they are always in orbit. And the flights, they also cross across multiple time zones, so they also have to maintain time. All this has to be done for navigation and for digital purposes. So that's why I think having a standard and maintaining that standard is very important. I mean, we don't realize how much important work goes on, and that is one of the reasons I selected this topic, because it impacts a lot of us.
Absolutely, absolutely. Not, I mean, it impacts a lot of people in IT a lot, but it actually impacts all of us. And it's good to know about it and all the calculations that are happening as you are receiving various info. I mean, in Outlook, if you at work, if I receive,
For
email
scheduling, yes.
from,
So
yes,
there are so many apps for scheduling that take the hassle of, okay, if I am at Pakistan and you are in Bangladesh and we have to coordinate a meeting from London with someone in London, how do you do
hmm
that?
exactly.
And that's how it works, because then you can go to that calendar, you just put the location, it tells you, okay, for this date this is the time and these are the overlaps. So at 6 a.m. in London it will be this time in Pakistan, this time in Bangladesh. So now you decide which time you want to select, and this will be the time for those people, and you can then select the meeting date.
Exactly, exactly. So yeah, I mean, UTC makes the lives of software engineers easier, not just that, but lives of everyone easier by consequence. So it definitely is a very interesting topic, and also it kind of opens the door for our audience to sort of think about the longitude and latitude and how the world is divided arbitrarily by humans, but it is divided and standardized and agreed upon by everyone in the world. So it is quite important, arbitrary or not, and it sort of answers a lot of questions about us as well and where you are in it. and when you travel and how things are being calculated. And to be honest, I actually remembered one of the questions I had, Amit, when you were explaining that. So, when we divided the Earth in, longitudinally and latitudinally, horizontally and vertically, we would end up with squares, right? One going in one axis, the other in
Kind of like a
right.
grid, yes.
Yeah, yeah. So there
But
is a
the
grid,
square,
but
it won't be exactly square because it's on a sphere.
exactly. That is my point. That the higher, the up further north or south you go, the shape of square would be less and less like a sphere, less like a square. So how does so that also means that the division, the vertical sort of lines
They
are
get
getting
closer and
closer and
closer
closer.
in the North Pole and South
So
Pole. So that's why the days are almost 24 hours and nights are almost 24 hours. So you must
right,
have heard
right.
about the midnight sun. So it
Hmm.
is because of that, because you are having constant, the sun never sets.
Hmm.
So
Yeah,
it's
yeah,
always
that's what
daylight. So because you're right, it comes down to that point. The sun never sets and the sun never rises. So that's the phenomena that happens because of the sphere and because of the way Earth is tilted on its axis and because of the way the sun, because of the way Earth rotates around,
because of the
orbits
tilt.
around the
I
sun.
think it only sets once every 6 months in North Pole, right? That's
Something
something.
like that,
Yeah.
and then it's the opposite in South Pole.
Yes,
So
yes.
you have the midnight sun, but then you also have darkness in winter for a very long time, and sometimes it's dark, dark,
So
dark.
So this is where it confuses me a little bit. So because of the vertical lines being closer and closer, the sun never sets, or the other way around, because the sun never sets. That's why
The
the
sun never
lines are
rises.
closer. Yeah. Now, but it doesn't affect the actual time that passes. I mean, it's still 24 hours in a day, right? But how do you define a day if the sun is not,
No, no,
you
no.
know?
So it is still. I mean, but at the Arctic Circle or Antarctic Circle, the
Mhm.
time, yes, it is passing 24 hours, but for them it is always dark.
Mm,
It is always
okay.
dark or always sunny.
Right, right, right.
What is
Okay.
your exact question? I mean, does
So
that
my
answer?
question is, I think I'm being confused with the actual daytime
And
and
the time
nighttime
zone and the
and the
time zone.
24 hours that's being passed, right? So, so the more, in the Earth is rotating once, which is 24 hours. But so on North Pole and South Pole, isn't it that you're moving slowly in,
Yes,
the
yes,
Earth?
yes, yes,
Right, okay.
yes,
So the distance between two vertical lines,
is
the Earth
also
is, yeah, you're crossing that less of a distance in a longer time.
yes,
Right. That's why it's still 24 hours.
exactly.
It's not like less than 24 hours in a
Yes,
day over
yes,
there, right?
yes.
So that's okay. So yeah, no, I mean, I was confused, but as I was explaining it, I
You,
kind of
yeah,
got that. But yeah, it's so interesting. I
it
hope the
is.
audience is as excited to know all of this as I am. And thank you, Amit, for going through all of this. I mean, I had actually very limited knowledge on that, but when you came up with the topic, I thought this would be an opportunity for me to learn, and hopefully the audience had the same sort of thought and are going away with an interesting outlook on how this affects our lives and how the whole thing works on a macro level as well. Yeah, so yeah, I
Yeah,
would urge again to the audience that if you guys have any questions on what we talked about, please do reach out to us, or if you have any suggestions, feedback, or if you'd like to join us as a guest, please do reach out. Our contact details are available in all of the medias that you can hear us or listen to us or see us in video on YouTube as well. So once again, thank you very much, viewers and listeners, for listening to this talk, and hopefully we'll see you again on all our upcoming talks.
thanks everyone. Bye.
Thank you.